Now let's learn some techniques to integrate more complicated functions. We'll start with integration by substitution, which is based on the chain rule. So recall the chain rule, the derivative of f of g of x equals the derivative of the outside times the derivative of the inside. So if we're integrating a function that looks like f prime of g of x, g prime of x, then that becomes the derivative of f of g of x, and then we can integrate using the antiderivative. So let's see how that would work as a substitution. So let's say we wanted to integrate f prime of g of x, g prime of x dx. We can do this immediately because I wrote it in such a nice form, but often it's hard to know what function is g of x and then which function is g prime of x. So we have to do, it's useful to do a substitution if you can't do it in your head. And the substitution proceeds by let u equals g of x, whatever we want to identify as g of x. And then we can take the differential. So du is equal to g prime of x dx. Okay? So this will only work if we can identify a g of x as a u, and we can identify a g prime of x dx as a du. So the integral then of f prime of g of x, g prime of x dx becomes the integral of f prime of u, and then g prime of x dx is du. Okay, so it's the indefinite integral here of f prime of u du. We know that's just equal to f of u plus a constant. So that's equal to f of u plus a constant. And at this point then we want to have the indefinite integral in terms of x. So we can substitute back u equals g of x. So that becomes f of g of x plus a constant, which we knew was the correct answer because this integrand here is just the derivative of f of g of x. Okay, so this method, integration by substitution, gives us a procedure to integrate. We have to be a little bit clever because we have to identify the correct u. So let's work a couple of examples here. So let's say example number 1. Let's look at the integral. We'll start with an indefinite integral. The integral of x times e to the minus x squared dx. Okay? So the idea here is to identify a u. We know that the derivative of x squared is 2x, so we can get an x here by identifying u as x squared. We're missing a 2, so it's possible to put in a 2 if we multiply by a half. So let's do this substitution. So we can let u equal, say, x squared. We could choose minus x squared also, but I want to choose x squared. And then the differential here, du, is equal to 2x dx. So then we have the integral of x e to the minus x squared dx becomes the integral. So we have our x dx instead of 2x dx. So we can multiply by 2. So we need to divide by 1/2. So we have 1/2, which we can pull out of the integral. And then we have e to the minus u. And our du, then we have a 2x dx, so du. Okay? So now we've reduced this kind of complicated integral, x e to the minus x squared dx, into an easy integral e to the minus u du. We know how to do that. So this is 1/2 what is the antiderivative of e to the minus u? Well, the derivative of e to the minus u is e to the minus u times minus 1 using the chain rule. So then the antiderivative here gets a minus sign of e to the minus u. And then, of course, we add a constant. So then we can resubstitute in the value of u. So u is x squared. So it's minus 1/2 e to the minus x squared plus a constant. Okay? So we've determined that the indefinite integral of x e to the minus x squared dx is equal to minus 1/2 e to the minus x squared plus a constant. That was a nice example. We can look at a second example now. So let's look at example number 2. This one we can do a definite integral, so I can show you how that works. So let's say the integral from 0 to pi over 2 of a trig function. I'll choose sine cubed theta cosine theta d theta. Okay, so now we're looking for a substitution. How do you do this? Well, we know that the derivative of sine theta is cosine theta. So if we choose u to be sine theta, then du will be cosine theta d theta. So then we have a u, which would be u cubed, and we have a du, which would be cosine theta d theta. So we let u equal sine theta. So then du is equal to cosine theta d theta. And then substitute in. So we have the integral of sine cubed theta, which is u cubed, times cosine theta d theta, which is du. So we know how to do a power law integral. So this is a definite integral. So we can proceed as an indefinite integral and worry about the limits later. But what I like to do is to change the limits as we do the substitution. So to change the limits, we need to look at what is the value of u when theta is equal to 0. So sine of 0 equals 0. So u takes the value of 0 when theta takes the value of 0. So the lower limit here is 0. And then you ask yourself, what is the value of u when theta takes the value of pi over 2? Sine pi over 2 equals 1. So u takes the value of 1 when theta equals pi over 2, so the upper limit becomes 1. So you have to be careful. As theta goes from 0 to pi over 2 for the sine function, u then goes from 0 to 1. So changing the limits, we don't need to substitute back. The integral of u cubed du is u to the 4th divided by 4th. We're going to put in the limits here. I'm going to use this symbol, a vertical line, from 0 to 1, meaning that we're going to substitute the limits here in the definite integral. The upper limit minus the lower limit. So here it's 1/4 over 4, 1 to the 4th over 4, minus 0 to the 4th over 4, which is simply 1/4. And that completes the integration. So let me summarize. We're learning integration by substitution. It's a very powerful method for doing integrals. It makes use of the chain rule, but often you cannot see the chain rule directly, so we use a technique called substitution. We have to identify g of x by u, and then we take the differential du is g prime of x dx. So we have to identify both g of x and g prime of x in the integrand. Here I work 2 examples. They're not particularly difficult, but they're ones that all engineering students should be able to do. I'm Jeff Jasnoff. Thanks for watching, and I'll see you in the next video.